In this part, we're going to be getting to the meat of the tutorial by actually assembling the shader that we need for the tunnel in Shader Forge. So let's get started by going to the Shader Forge menu, and creating a new particle additive shader, and just saving it anywhere, and I'll just name it additive particle shader, like that. So if we just pass in our caustic texture that we generated in the last part, we'll see that there's an issue where the alpha doesn't actually show up. And for that, we just need to go ahead and quickly hook up the alpha over here. And there you go, right? So the first thing we'll need to do after that is to actually start panning the UV so that the texture starts scrolling across the geometry. Anytime we want to do that, first we'll need a time input. So we'll get the time. Then we'll need two value components for the actual multiplication and how fast it'll go. So we just hit V, go to the green value little node here, and the difference between the green one and the gray one is that the gray is a constant inside the shader. This one is an exposed property for the material. So we'll name this one maybe uSpeed main, as in it scrolls the main texture, and then we'll call this one vSpeed, also main. We then need to pass these in to an append component, which will basically combine them into a vector 2. And then create a multiply component and hook up this as well as this, which will then be added to this using a UV coordinate. So if we do this, pass in the UV here and this here, it'll add the result from this to the UV coordinates, which will then be passed into the main texture and then allow scrolling. So if we set this to, let's say, 0.1, it should show some scrolling, but it's not. So to test it out, we'll just go ahead and maybe create a new material. Let's hide this first so it doesn't get in the way. Create a new quad, and then create the new material. So we'll go ahead and create new material. We'll call this additive texture material. And set the new shader that we just created to be there. And then apply that to the quad over here, like so. And see what that produces. Compile the shader, and you can see it is actually scrolling. I just needed to hit compile, but this is good because we can preview it anyways. So we can change the speed like this, right? Whatever we want. Let's set up the fading from the bottom to the top using the gradient that we made in the last part. So for that, we'll create a new texture component, texture 2D input, and we're going to create a multiply component here. This can go into this. Maybe this can actually go into this one right here. And then we only need, let's see, where's the gradient? Gradient, we'll use this one. We only need the R channel, and then pass this in here. So if we set this, and we look at this, right, there's no difference yet because we have to actually assign the texture like here. And let's choose the gradient, this one, and now it fades as it gets to the top, which is exactly what we wanted. Okay, so now that we have that simple thing going on, we can actually go on to the distortion part, which is a bit more difficult and complicated, but still doable. So for that, we again need to have a setup like what we have here, because we'll need to have separate scrolling and distortion for the noise texture. So we'll create a new time component. Again, we'll create two value components for the U and V for the noise texture. We'll call this uSpeed noise, and we'll call this vSpeed noise. I gotta zoom in because I realize I'm really far away. And then we'll pass this in again to an append component node, pass it in like this, and basically a multiply component like so. And then finally add that to another UV coordinate node using this. Right, so we've got our scrolling for the noise texture set up here, but now we actually need the noise texture, so let's add in a texture 2D, which takes in the noise map that we generated and passes that in directly like so. And let's see if I set this to 0.1. Is it scrolling? Yes, so we got our scrolling noise texture, and we basically need to interpolate that with this. So what we'll do is create a lerp component, and let's see, we'll need a noise amount controller, so we'll create a slider for that. We'll call this noise amount, so how much of the noise we actually want to use. Pass that in as the T to the interpolation, pass in the R channel to B, and for the first one we'll need, of course, another UV coordinate, so we'll hit U on the keyboard and then select this and pass that in as A. So that should give us, there we go, interpolation, like so. And then we can pass that in. Instead of using this, we can just pass, we can delete this, select this, delete, and pass that in as A. And let's compile that and preview it in Unity, see if that did anything for us. Select the noise texture here, which I forgot to name, but okay, not a big deal. And we can see how that distorts the texture like that, which is exactly what we wanted. All right, so one final thing that I didn't cover is that, let's say, for example, I had a cylinder like the ones I have here, which we'll make in the next part, but I'm just going to show you something real quick. Let's say we had the cylinder using our new material that we just created, right? We see that there is actually a problem with the noise. When the noise isn't there, it actually loops perfectly. Let me just turn this up to something like blue. Okay, so we can see it loops perfectly around the cylinder, but if we turn the noise up even a little bit, it starts clipping right there. So what we need to do is basically fade it out around the cylinder so that there's no noise on this part, distortion, and that way we won't see this clipping, right? So that's really easy to do, and that's where that centered linear gradient comes in handy. And by the way, a lot of these, like this noise texture, you could generate it on the shader itself, and that has advantages and disadvantages too. Advantages being that, you know, it's going to have really high bit precision, no compression, but it's also more performant to just use a texture, and it's also easier for us to set up the nodes that way, so that's why we have it done that way. So anyways, for this, what we can do is pass in, let's say, another lerp node. Also, while I'm here, I'm just going to name this noise text or something, I guess. And anyways, so we have our new lerp component here. We'll create another texture input. We'll call this the noise mask. The noise mask will be our centered linear gradient, the really hard-edged one. We'll pass in the R value as the T. We'll pass in a fresh UV coordinate node, like so. And then for B, we'll actually pass in this. So based on this texture, it's going to, you can see it, you can just barely see it, I guess. But if I just turn this up, you can see how it fades to the corners. And then there's, you know, nothing there. It's just using the regular UV coordinates. And that way it's going to help us wrap around our cylinder or any other sort of spherical object that wraps around. And then we'll pass this in, instead of directly from there to there, we'll pass this in here. Hit compile. And that should fix our problem once we pass in the noise texture again. So we renamed it, so we have to pass in the noise texture again. And maybe set the noise mask to the centered linear gradient, like so. Let's test this out. So you can see now there's no clipping because as it approaches the actual wraparound, it just goes back to using the regular UV coordinates rather than the distorted UV coordinates. And that way we don't have the clipping issue. So I think that's it for this part of the tutorial where we generated the shader. You can change the color up, right? There's a lot of things you can do. And in the next part, we're actually going to be making this cylinder that you see here using ProBuilder and finishing up the bulk of the effect.